Come on. What is that? The ocean is where weird comes out to play. An alien-like underworld with animals and events just so bizarre, it's hard to believe they exist.
That is the craziest looking thing.
The brain is just struggling to work out what's going on.
I thought I was hallucinating.
Can science explain any of this weirdness? What's the reason behind these glowing creatures, unidentified floating objects, and these mysterious disturbances in the water? I'll examine the evidence and speak to experts and eyewitnesses to discover what's really going on with the ocean's weirdest natural phenomena. What's the weirdest animal in the ocean? I gotta say a jellyfish, for sure. Oh, I was right. Jellyfish. Immortal jellyfish. Wow, that's weird. They might not have a proper brain, blood, or even a heart, but some jellyfish species can live forever. What are their secrets to survival? Hey, Kylie, how are these things alive?
Jellyfish are really simple creatures. So they effectively consist of a layer of tissue that covers the outside of their body and a layer of tissue that covers the inside of their body. And between those two layers of tissue is mainly water with a few collagen fibers.
Okay.
And they can grow very quickly because they're effectively 95% water. Jellyfish are so simple that all they really need to do is to add more water to their body. They're almost like a little bit like a water balloon.
A body that's mostly water is great camouflage in the ocean. And they need to hide because they can't really see their predators coming.
So they have very simple eyes.
Jellyfish have eyes?
Yes. But most of them can detect just changes in light intensity and perhaps light direction, but they certainly can't form an image.
Mm-hmm.
They don't have a well-developed brain. They've got a very simple nervous system, so they can probably respond to stimuli, but they have no cognitive ability.
Who needs eyesight when you can shoot venom? Underwater cinematographer Dean Kropp has swum with deadly jellies.
Some jellyfish have stingers. They've got nematocysts that they can sting you with, and some are very, very deadly, especially the box jellyfish, which I grew up with up in far north Queensland. I've been stung on my foot, and it was so painful. I screamed and I yelled and I said many, many horrible profanities. The reason their toxin is so strong is it catches animals and feeds on them. And if that animal isn't immobilized straight away, as it kicks and struggles, it will just tear that fragile jellyfish apart. I was lucky because other people who do get hit on the chest or the neck, it can cause you lifelong damage or it can take your life.
There's another variety that's just like the Terminator. They just won't die.
So typically with a jellyfish life cycle, the life cycle goes in one direction. So you have the medusa that produce the larvae produce the polyps, and then the polyps produce the medusae again. But we found that in some species of jellyfish, they're actually capable of reversing their life cycle.
Wow.
So there are some species where the medusa can actually revert back into being a polyp form. It can actually just swim back down to the sea floor and it will just slowly revert back into this tiny little polyp form.
Wow.
So those polyps could persist potentially for multiple years, and it restocks the population of medusae every season. In theory, it could be immortal, but in reality, something will eventually kill it. So it's unlikely to be truly immortal.
Many animals are facing extinction, but some jellyfish species are exploding. They gather in masses or blooms.
I had an extraordinary experience with jellyfish off of the east coast of Newfoundland, Canada, in Terra Nova National Park. We accidentally stumbled across this massive bloom.
Wow.
From the surface of the water all the way down to about 15 meters of depth were solid jellyfish. It felt like being in this mass of squishy rubber balls. It was almost as if it was an organism in and of itself. Being able to see sort of the beauty and grace of their swimming, but also to look inside and see what they've just eaten is incredible. It was so exciting to be in and amongst them. I literally wanted to breathe every last breath out of my tank before getting out of the water.
Bloom encounters seem to be happening more often.
So the blooms might occur just because of the aggregation that's driven by currents. A female Medusa will produce thousands upon thousands of larvae.
Wow.
So it's a really prolific way of reproducing.
I think in terms of the weirdness scales, I thought it couldn't get any weirder than the 4 penises on an echidna. But jellyfish have got to be, they're immortal, no blood, no ears. They can grow up this big and never die. That's weird. Whoa! What is that? What is that? I have genuinely no idea what that is. Is it a sea monster? Huge, hairy, and faceless. The objects in these photos aren't like anything we can recognize. We've only explored 20% of Earth's oceans. So, are these mystery blobs just an undiscovered creature of the deep? Whatever that is. For centuries, unidentified creatures have been washing up on our coastlines. The first photographed case was in 1896. These bizarre things even have a name, globster, glob monster, a term that made waves in the 60s, when something unexplained washed up in Tasmania.
This is Hobart. The island is famous for its apples, for its scallops and for its hops, and now it's got a monster on its hands. All over the world, people want to know what it is that's been found on the beach up on the west coast here.
So in winter 1962, stockmen stumbled upon this giant blob covered in short fur, really terrible odour coming from it, no eyes. What was it?
The first man with any scientific training who went there and who looked at it was Bruce Mollison of the CSIRO. In the cold light of a Hobart early morning, what is it?
That I've always avoided saying. My main interest in it lies in the fact that I don't know what it is.
Many people thought this could well be the discovery of a new species.
Does it resemble any known living creature? None that we can think of, and we've also looked at some fossil records.
It certainly looked fairly odd in the photographs, so a lot of people from all over the world started writing to CSIRO and to the Tasmanian Museum asking for more information about it.
Using an electron microscope, the Tasmanian globster was later identified as whale collagen, although some locals still refer to it as a monster.
This has gone on for decades, and I still talk to people that say maybe the scientists have got it wrong, maybe there's a conspiracy theory, whatever. People still want there to be a monster, a sea monster out there to be discovered.
Hey Vanessa, I'm going to send you some photos and I need you to help me figure out what the hell I'm looking at here.
Okay, I love looking at these. Now, at first glance, I see something that's been weathered, been dead for a long time, and is probably not smelling too good if I was too close. But still, I don't see any features or any bones. So in this case, we really need to then go beyond the image, and that's where genetics and DNA would be key to potentially identifying what this is.
It doesn't seem like we're going to solve this mystery today. So what about this one? It looks extraterrestrial.
It does look like an alien. When you see this, it's got this protruding head-like shape. So it kind of looks like a brain, but it's not. What you can see here is a baleen whale.
A what?
Baleen whale, so a toothless whale, because I can see those really clear throat pleats which extend from the throat all the way down to the belly.
It's an upside down whale, of course. It's the chin thing.
You are staring directly at its stomach and its private parts. And if I zoom in here, we may have a female humpback whale. I can see two little dots on either end there, which indicate to me that this is most likely the mammary slits, or in other words, its breasts.
Another witness's photo confirms it's a baleen whale, specifically a humpback.
It's a humpback whale and it's very bloated. After a whale dies, there's a lot of gases which build up inside their body, and there's no exit point, or at least their mouth or the bottom isn't working at this stage. So over time, they'll find an exit point for the gases to go out, and the animal will deflate and will potentially float down to the bottom of the sea.
A dead whale might seem like a bad omen, but it's good news for some.
My island people have a dream time story. We call it the sleeping whale. The ending of that whale dreaming is the whale went to sleep in this certain bay. And that certain bay is prime area where everybody wants to go to. The oysters are massive. It's like how science see it today. When the whales fall to the bottom of the ocean, they become part of that sea country and they give back to the country.
Whale falls can also help fight climate change.
We know that they store a lot of carbon in their bodies. We're talking about an animal 40,000 kilograms, the size of a bus. That's a huge amount of carbon going down to the ocean.
In terms of how it ranks, that's got to be up there. This is next level. This is next level weird. These photos are cooked. Why? That's that's a lot of seafoam. Edible? Seafoam. We're used to seeing seafoam lapping at the shore, but some Aussie beaches have seen huge amounts of this stuff. Just don't read the comments because they say it's whale sperm.
It's definitely not whale sperm.
That's an interesting one. If you put the foam under the microscope, it's just foam. You don't see little sperm swimming around.
So what's causing this onshore bubble bath? And is it safe? Seawater is only 96% actual water. The rest is particles of salt, plankton, algae, protein, fat, you name it. If I shake up seawater, bubbles form. Now let me show you that against tap water. Now that's what I call a frothy.
As soon as you start shaking it, the foam immediately appears. And so that mixing can be big waves or a storm or tides forcing it through some narrow area, whatever is giving it enough physical force to actually mix that water up. When you get like a meter or two of foam on the beach, I can almost guarantee you that immediately offshore, there's some big phytoplankton bloom.
Phytoplankton are like tiny plants. Think algae.
And it's probably the dominant organism in the ocean at the moment. It's just got the right conditions to keep producing all of these chemicals, and then they just come washing up onto the beach.
Surf photographer Ted is lucky to have seen this phenomenon a few times.
It's dynamic, it's moving, it's like this living organism. There can be areas where there's foam, but no ocean underneath it. The cars driving into the foam, oh my God, it's like going to the abyss because it was obviously quite dangerous for the cars.
Oh, there's a car! What a dickhead.
It may look like a giant foam wall, but a tiny kind of molecule gives foam its shape. To get bubbles, you need surfactant molecules. These molecules have one end that's hydrophilic, which means they love or attract water, and one end that's hydrophobic, which means they fear or repel water. And when these molecules mix with the water and the air, one end faces the water and one end faces the air. And the easiest shape to make in that situation, the one that offers the path of least resistance, is a sphere or a bubble. They photograph well, but sticky molecules aren't always a good thing.
So this was in Monterey Bay. A lot of birds ended up showing up on the beach and dying.
The birds were covered in yellow-green slime.
They took some samples and they determined it was not petroleum products. It turned out that it's something we'd never seen before.
It was seafoam.
So this foam, it turns out it's a relatively small molecular weight protein that has surfactant properties. And so literally it's damping down the feather.
The protein was being released by a nearby plankton bloom.
It destroys the waterproofing of the bird feather. They were freezing to death because normally the feathers keep that cold seawater from touching their skin. It's really just an unfortunate coincidence that it happens and has such a negative impact on birds.
Should people be swimming in it or riding their bikes through it?
Seafoam's sort of like that conglomeration of sort of different decaying particles of the mucilage from the phytoplankton blooms. So it's definitely a lot of bacteria in there. So it's a good habitat for a whole lot of different microbes. In Australia, the kind of level of seafoam that we have, it's not dangerous to humans as far as I know.
So, are we likely to experience more seafoam events in the future?
With climate change, we also get more storm events. And so it's at least possible that for the blooms that we're seeing that are causing the foam that actually impacts the birds, that it might become more common, which is something that we're worried about.
Don't go anywhere. There are more head-scratching moments to come.
I thought I was hallucinating.
That's an enormous wave.
Wow. I don't think I'll ever go into the ocean again.
What if I told you that there's waves out there that glow in the dark?
I'd say, what have you been smoking? Whoa! Okay. That's not real.
It is.
That's
sorry.
real? Yeah? That's real footage. Wow, that's cool. Glowing waves. It's not a camera trick. The water is actually flashing and glowing. What's causing this light show? And is it safe? The photos from Jervis Bay in Australia are out of this world.
But it's real. Whenever you see videos on the internet, that's actually what you see with the naked eye. When I first saw Bio for the first time, I thought I was hallucinating. I had absolutely no idea what it was.
What's going on? What's happening? What's that called?
Bioluminescence.
Bioluminescence.
Bioluminescence is the generation and emission of light by living organisms, phytoplankton generally. So microscopic organisms.
Like land plants, phytoplankton perform photosynthesis.
They contain these light harvesting pigments and they can discolour the water. And this discoloration can be anything from a bright red colour to pink to brown to green. And then at night, when that light is not externally present, they are able to generate their own light through bioluminescence. And this is a completely different colour in that sort of milky white blue glow.
Often the glowing plankton is Noctiluca scintillans, also known as sea sparkle. Dean was sailing overnight when a glint caught his eye.
It's pitch black everywhere, but clear as day below us are these amazing, beautiful dolphins glowing bright blue and green in bioluminescence. The brain is just struggling to work out what's going on.
The dolphins were, you guessed it, swimming through bioluminescent plankton. It seemed to intensify as there was some sort of movement connected to it. What was causing that?
Often mechanical stimulation causes this chemical reaction between luciferase, an enzyme, and luciferin to generate oxyluciferin as the product. And in that process, light is emitted.
This chemical reaction is like cracking a glow stick. But plankton aren't the only critter with this special skill.
Interestingly, the ocean contains most of the organisms that bioluminesce. So they include fishes and squids, bacteria, worms. Anglerfish that live in the deep ocean have a lure at the front of their heads, and this enables them to attract prey that unsurprisingly get caught out when they venture too close. And then things like phytoplankton bioluminesce, and we don't really understand why. But there are some studies that show that phytoplankton that bioluminesce are consumed less by zooplankton. So it may be also a predator evasion tactic.
So why does this happen in Jervis Bay of all places? Well, it's simple geography. You see, the bay's restricted entrance and limited tidal exchange means that whatever comes to the bay stays. 20 years after his first encounter, Jervis Bay local David Finlay has become a bio junkie.
I could literally see bio every night in the water and the excitement wouldn't wane.
David, so what I've got here in front of me is a photo. You're nude and blue.
That gets a lot of mileage, that one.
Can you please explain yourself?
So I don't recommend this. This is one of the crazy things that I've done. Tasted terrible. Yeah, I got it in my mouth and I had to spit it out. It just tastes absolutely disgusting. And I smelt like bio for 2 days, even though I was scrubbing really hard to get rid of it.
Like a fishy odor?
It smells really bad. It has like a very, very rotten ammonia smell. And actually, that's one of the byproducts, I think, that Noctiluca scintillans gives off.
If you see it and you want to jump in the water, is it dangerous?
I wouldn't recommend swallowing seawater with lots of noctiluca in it. Not good for your microbiome. It's certainly safe for children to splash in and so forth, but just give them a good bath.
Wow. I didn't know that whirlpools existed in the ocean. That's a scary thought. I don't think I'll ever go into the ocean again. Yeah, I said it. Ocean whirlpools. Apparently, they're a real thing. In fact, one of these puppies is bigger than the state of Tasmania. So, how do they form? And can they swallow up whole ships?
Whirlpools are almost something out of like sailors' tales from like the 1700s. Like you imagine, pictures of a whirlpool in a ship and like a giant squid. It almost feels like that. You can come up next to these in a boat and the water is just circulating so powerfully. Just the actual power of it is just so impressive.
Growing up as a saltwater traditional person, we're told, pretty much don't travel over the straight spring tide because the whirlpool, is more active. It sort of like, comes alive sort of thing. The tides are very dangerous. There's like a pull,
Let's take a closer look at the physics. The swirling motion is sucking the water towards the center and down. It's kind of like a tornado, but a whirlpool has a downdraft rather than an up. The column of air forms because the vortex is rotating the quickest in the middle.
So the whirlpool we see in very coastal area where there's very strong current from the tide. It's really the tide that is the main factor and the geometry of the place.
Tides move water up and down, while currents send it side to side.
And because they're very strong and have this high velocity, they're going to create turbulent flow, and that's when those whirlpools are generated. And those ones can be 10 times faster than a large-scale ocean circulation pattern.
Ocean whirlpools kind of like toilets? Is the spinning direction different in different hemispheres?
The thing that we're saying is responsible for these rotating in different directions is the Coriolis force, or the Coriolis effect.
The Coriolis effect happens because the Earth rotates faster at the equator than its poles.
But on a really small scale, that effect is not measurable. So if your water is actually rotating a different way in a different hemisphere, it's got to do with the geometry of your bathtub, and that's it.
Okay, cool.
But it's not surprising that on a much, much larger scale, when you're talking about these huge whirlpools or hurricanes or these big, huge masses of air and fluid and gas and everything, they will feel the Coriolis effect.
Large Aussie whirlpools rotate clockwise, but it's the opposite in the northern hemisphere. How powerful can they get?
You can have 10 to 20 kilometers per hour of speed of water swirling around in a whirlpool.
Wow, okay, wow.
I don't know any cases where boats have been sunk by whirlpool. However, it's always a dangerous place to be.
But I mean, you never say never. The world is an interesting place.
What's the biggest wave you've ever seen?
7 meters.
We measure waves close to 10 meters.
About 14 meters.
A bit taller than 20 meters.
Wow, that's a big wave. No. I'm in awe and I'm scared of that. Rogue waves. These giant walls of water aren't tsunamis. They're not caused by earthquakes. But they're just as deadly. So what causes a rogue wave? And can they explain the mystery of the Bermuda Triangle? Hi Justine, so you surfed a wave taller than 20 meters. That's about the size of a building. Were you scared at all? Were you nervous?
Sometimes it's like scary afterwards, because when you see the picture and the footage, you're like, okay, wow, that was huge.
But despite its mammoth size, this wave isn't considered rogue.
Rogue waves are waves that are over twice the height of all the waves surrounding them. So if we have waves that are 2 meters high on average, a rogue wave is defined as something that's more than 4 meters high.
That day, most waves were hitting around the 15 to 18 metre mark. So Justine's 20-odd metre beast wasn't double, wasn't rogue. Imagine calm seas, and then out of the blue, an 8-story tall wave. That's a rogue wave. It's the unpredictability that makes them so dangerous.
There are incidents reported where a ship has been smashed by waves. The windows has been smashed out by the wave. The engine stopped, then the ship is in trouble.
Rogue waves have been observed by mariners for centuries. They've seen these rogue or freak waves and reported on them as they've come back. But it wasn't until January of 1995 when we actually observed the first rogue wave. And it was observed at the Dropna oil platform off the coast of Norway. The waves were about 12 meters, and the rogue wave that was recorded was 25.6 meters high.
Wow, that's a big wave.
That's an enormous wave, and it's really the biggest rogue wave that has been recorded to date.
So what causes rogue waves?
One way is around having multiple wave trains, so series of waves traveling and interfering with each other and adding and subtracting together. So if you imagine you have 2 waves that are 1 meter tall each, and they happen to occur and overlap, then you'd end up with a wave that was 2 meters tall.
The convergence of 2 waves is known as linear behaviour. The model for this theory suggests rogue waves should be rare, but they're not. So some scientists theorise non-linear behaviour is also at play.
In the nonlinear world, this wave will start to talk to each other. And one of them will start asking a little bit of energy to its neighbor. And then that's not enough. We will ask energy to the other neighbor. That's not enough. Enough is never enough. So we'll start getting energy from all different neighbors.
Non-linear models help explain chaotic systems, like how weather forms or how water can suddenly go rogue.
And this phenomenon, which is basically an instability process, will occur very quickly and very quickly will disappear so that the wave field will go back to normality again.
Meaning rogue waves are chaotic and hard to predict. So could these agents of chaos be the answer to the Bermuda Triangle mystery?
As far as I'm aware, there aren't actually any more shipping disappearances in the Bermuda Triangle than anywhere else around the world relative for its area.
There is no evidence for that.
In terms of physics and science, that rogue waves, as we know them nowadays, can in principle occur everywhere. The straight answer is everything is possible.
So there you have it. After taking a deep dive into its strange phenomena, what is that? What is that? I can confirm that the ocean is even weirder than I first thought. That's going to be the weirdest thing I've seen today. Whatever that is the winner. But it's also beautiful and a bit terrifying.
We talk about down there being weird and wonderful, but it really is, and that's exciting. I love it.
Many things seem unbelievable.
Now it's got a monster on its hands.
But science can usually explain what's happening. As long as people keep asking questions, experts will find the answers. Thanks for watching. Check out more weird and wonderful videos here. And if you like our stuff on ABC Science, then please subscribe. See ya.